let's continue on this 3.6 to discuss about the abstraction of ArchiMate language. For this second part is we will discuss the different way of modeling in ArchiMate based on their abstracting the concepts. So first of all is in the mind map, I give you this link, which mentioned here in the this reference. So where in this video we talk about this two paragraph, and here is this number 6 are this G21E, which is our article, or you can see that is our white paper to how to discuss how to use ArchiMate modular language to support TOGAF standard. So from this article, you may see the relationship to see that linking this ArchiMate specification used with this TOGAF standard to support business transformation using the enterprise solution and other architecture activities. So you can also log in to download that if you have interest. And I will not go to detail for that. I give you this link. Number is G21E, which you can search in this public publications within opengroup.org. So that is one useful information file. And then the what about this three way of modeling those abstractions we discussed on the earlier video. So if you keep in mind is that there's three distinctions when we talk about the ArchiMate abstraction. So first way is the behavior element can be used to model logical components. The corresponding physical components can then be modeled using active structure element. So active structure element will be used model physical element. Behavior element can be used to model logical element. So that will be the depending on what you are going to model. So if we look at our document here, so if I make that a little bigger, so here, so since this why we see the behavior element modeled logical is because they represent implementation independent in-cap solution of functionality. So because that is kind of those behavior is independent on different implementation. And then there is the second part is also which means that they have some dependencies already. And the second way is the ArchiMate support the concept of realization. So these can be best to describe by working with the technology layer, the upwards. The technology layer defines the physical artifacts and the software that realize an application components. Physical artifacts and the software, they can realize application components. What that means? So I still use over this dummy the diagramming. So if I put in that all of this select and move that a little bit here. So I have one artifacts. And also I have one software you already see here. And then those two are some these components within the physical layer. I can use the realization. So you can see here, this software can realize over application. So and if I use the realization still, so artifacts can also be allowed to realize application. So with those is that is the a valid relationship, and you can also use this way to tell the story or the message is I have a certain the physical or the technology artifacts implementation, then that's realize this application or this solution. Similarly, is I implement our software, no matter this operating system or the database software or middleware or even the some of your application. If they treat it as a system software, that can be the components that we can use to realize our application component. And ArchiMate also provide a mapping to other physical concepts such as the device network needed for realize an information system. Because as I already mentioned here, you can put a device inside a node, but this device can directly be used to realize our application. So if you want to skip this node level, that is allow. So realization is quite frequently used relationship is because realize means is you have something, this something make another something happen, and realize means is make that getting real of either the function or these requirements. So the realization relationship also used to model more abstract kind of the realization, such as between requirements and the principle. So the requirement is more specific, principle is more generic. So this sample is coming from the motivation layer. So requirements is this one is like this shape. Principle is this one. So it's like it's exclamation. So if you check is the part is you can see you are also allowed to use the realization. So which means is if you have a principle, so like is all the applications due to the regulation constraints must be implemented in this country or this market geography locally. That will be our principle. Then your requirement is I need to host application in both this application layer and the data layer inside the geography boundary. So that will be the translated the requirements to your strategy layer to your business layer. So those are also from the more generic translated to the more specific, but within that is we can also tell the message is your requirements if that is fulfilled or will realize your principle. So that is the further used by the realization. So realization is also used between application components and between node. So which is I already put here, but I use this serving. But you can see is I can change that to realization as well. So all those realization is quite flexible for you to making the abstract conceptual design. This way, you can model a physical application or technological components realize a logical application or technology components respectively. So that is the second one. So realization. So try to keep in mind for now when we talk about the relationship chapter is we will specifically make the realization in clear definition, and we also may have our sample to do the model in the Archi2. And the third one is logical and physical application components can be defined as a meta model level specializations of the application components element. So what that means for the modeling. So this is we'll look at this chapter the 14. So what is chapter 14? So if I put here is a language customization mechanism. So the same hold for the logical, physical, technology components of TOGAF content meta model, which can be defined as a specialization of node element. So those one is I don't want to go to detail for that, but keep in mind is in the last video we mentioned these three levels, but in the certain ArchiMate related tool, you may not see those levels directly. But when you model or architecture the landscape, is you may try to see some the components or notation you are modeled is maybe in this logical layer, some in the conceptual layer, some in the lower physical layer. So those can be still the different abstracting levels when you do the modeling. So those one is when we come to the those 14.2 is then we will talk about specialization of the application layer in more detail. So for now, is I will not go to this part detail. And last but not least is for this modeling. So if I back to here, so you may see here is the ArchiMate. We need to remember one the notice thing is ArchiMate as a language is have some intentionally doesn't support a difference between type and instance. This is not the important when you just use the Archi2, for example, because Archi2, if you want to see here, I have components, I have inside components. I just use this composition relationship. Then I have the hierarchical, but you don't distinguish which level are class, which level are instance, which level are type. But those the concept will be crucial when you build our ontology, because ontology you will have the different entities. So until now, what we build are only the classes. And if we are going to do is the individual, which is the instance or the type of those classes, then that will be defined clearly is the individual will inherit all the properties coming from this common class. But this kind of the hierarchical structure and the distinguish are not supported by ArchiMate. ArchiMate just gives you a list of the notation, grouping them into the different layers, and we may also have the aspect, try to make those classification during this relationship connection. But you are not looking at ArchiMate to tell you the class instance or class individual distinguish. So those keep in mind is, and also this is also as the reason is why I put this course package this I want to show you when we read this ArchiMate 3.2 specification. They introduce our meta model, but this meta model is still being able to be translated, described by our ontology view. In some chapter later, you'll see here is we may also discuss this semantic the view for certain the topics, but we are intent to build the ontology for describing the meta model. Even ArchiMate language doesn't need to show this distinguish. At the enterprise architecture abstraction level, is more common to model type and all exemplars rather than instance. So we just keep a model and breaking down them. You still use the same notation, just in the different level. Similarly, the business process in ArchiMate language doesn't describe individual instance. For example, one execution of that process, we select a business actor. That is just a representation of the owner, not our Jack or that is a Scott. So in most cases, a business object is therefore used to model our business object type, like our UML class, of which several instances may exist within the organization. So we are not too much distinguish that. So those are the some the core message is I use these two videos to tell you, try to make those abstraction distinction and try to understand the different way of modeling that designed by the ArchiMate and what's this intention to do that. Next video is just closing with this some more the definitions, then finish this chapter 3. So bye for now.